Example 3 says, find f prime of x if f of x equals the quantity x squared plus 3x minus 4 times the square root of 9 minus x squared. For this one, we're going to need to use the product rule. So we have first times the derivative of the second. Recall that this portion here is the same thing as 9 minus x squared to the 1/2 power. So I'll bring the 1/2 power down, and I have 9 minus x squared, and then the new power would be negative 1/2. And then from there, I need to use chain rule and take the derivative of the inside, which would be negative 2x, plus, so we did first times the derivative of the second, plus the second times the derivative of the first. So that would be 2x plus 3. Okay, so this 2 and this negative 2, or this positive 2 there will divide out. So we'll have negative x times x squared plus 3x minus 4 over the square root of 9 minus x squared, and this is negative here, so that's why it's in the denominator, and I changed the 1/2 back to the square root symbol, and then plus 2x plus 3 times the square root of 9 minus x squared. From here, if we wanted, we could simplify this by combining it into one fraction, and that would require taking or finding a common denominator. But this is fine getting up to this point. So here is our derivative. Example 4 says, suppose that the weekly revenue function for a product is given by R of x equals 36 million x over the quantity 2x plus 500 squared, where R of x is the dollars of revenue from the sales of x units. Part A says, find the marginal revenue function. So for part A, we want to take the derivative of the revenue function, and that's going to require quotient rule. So we want to take the bottom times the derivative of the top minus the top times the derivative of the bottom and then we need to make sure that we're using chain rule and take the derivative of the inside function, and that's going to be 2 all over the bottom squared. And let's go ahead and clean that up a little bit. So we're going to get r prime of x equals, let's factor out 36 million. And let's also factor out a 2x plus 500, since there's 2 here and there's 1 there. And then what we'll have left is 2x plus 500 minus, let's see, that's going to look like 4x, I think. So if we simplify that, that would be negative 2x plus 500. So I'm going to go ahead and erase that. And then we'll have 2x plus 500 to the 4th power in the denominator. And then we can cancel that with one of these. So that can change to a 3. So we have r prime of x is equal to 36 million times negative 2x plus 500 over 2x plus 500 to the third power. So there's our derivative function, or our marginal revenue function. Part B says find the marginal revenue when 50 units are sold. Now I am running out of room here, but let's see. I'll do part B over here. So what we want to do is we want to calculate R prime of 50. So I'm going to plug that into the derivative that we just found. So we have 36 million times -2 times 50 is -100. So our numerator would be 400 over 400 cubed. No, I'm sorry, that's not right. 2 times 50 is 100, 100 plus 500 is 600. So that would be over 600 cubed, which is going to simplify to 200 over 3, which is approximately 66.67. So what does that mean? That means that the marginal revenue is $66.67 when 50 units are sold. Another way of saying that is the predicted revenue from the sale of the 51st unit is approximately $66.67.